Hi, today we're going to be doing power functions, and you have a quiz on February 3rd. Some of the important things you need to know is 6 of the parent functions discussed yesterday are power functions. The definition is any function that can be written in the form f of x equals a times x to the n. A and n must be non-zero constants, and that is a power function. Please have that definition in your notes. A is called the constant of variation, another definition that needs to be in your notes. N is the power. Another name for the power is an exponent. Another definition for your notes. The 6 basic power functions are below. You do need to have this table in your notes. The left side is the way it will probably be given to you. The right side is the correct way. So if you notice where it says f of x equals the square root of x, you would convert that into f of x equals x to the 1/2. And that's because it's a power function, so it needs to have an exponent. The way to convert this to exponents, and don't forget, you do need that table in your notes, so pause the video if necessary. Down here, I have shown you how to convert. If you have a root and you have a number in the crack, and then an exponent, then you would rewrite that to power over crack. So if you have the 6th root of x to the 5th, you would rewrite it as x to the power, which is 5, over the crack, which was 6. So that's where I get that from. And further, if you have a fraction, like f of x equals 1 over x to the 5th, to turn that into a power function, you needed to bump that exponent to the top. So that would be written as f of x equals x to the -5th. All right, so let's do some examples. The first thing, this is determine if the following functions are power functions. Write in the appropriate form. If not, already there. So, number 1, f of x equals 5.2 to the x power. Is this a power function? The answer is no. The reason this is not a power function is because the exponent is a variable. In power functions, the exponent is never a variable. It's always a number. So number 1 is no. Number 2, is that a power function? Yes, the exponent is a number, not a variable. So this is a power function. Number 3, is that a power function? Yes, it is, but remember we have to convert it to the correct form. You cannot have the exponent on the bottom. So if you look at my example here, if you have an exponent in the bottom, you need to bump it up and add a negative. And yes, it is a power function. Is number 4 a power function? Well, you do have an exponent that's a number, but you have a whole bunch of other stuff that makes it not a power function. If that was gone, it would be, but because that's there, the answer is no. It's not a power function. So the biggest thing with power functions is solving the following equations. What you need to know is roots undo exponents and exponents undo roots. Another important thing you need to know is if you take an even root, you must put a plus or minus every time you take the even root. So my first example asks me to solve this. I have an exponent. To undo an exponent, I use a root. It's a square, so I'm going to take the square root. So the square root of x squared equals the square root of 300. So that's x equals, and I need to go to my calculator to figure out what the square root of 300 is. 500 is 17.3205. 17.3025. Now, what's important? I took the even root. When you take the even root, you must use a plus or minus. All right, so now this next example, example 2. This time, first, I have to get the cubed root of x by itself. It's not by itself. So I need to divide by 5. Now that the cubed root of x is by itself, you need to do the opposite of the cubed root. The opposite of a cubed root is a cube, because to undo a root, you use an exponent. So I'm going to cube this. And that gives me x equals, and I'm going to do the cubed root. Sorry, not the cubed root, but the cube in my calculator. I need to put the fraction in parentheses. So 12 over 5 to the third power. And that gives me 1,728 over 125. So 1728 over 125. All right, the next example has an exponent, and to undo an exponent, you use a root. So I need to take the negative cubed root. So that's the negative cubed root of x to the negative 3, and the negative cubed root of 247. And that gives me x equals, and to do the cubed root in your calculator, you do negative 3 in parentheses, because that is what's in the crack, math, option 5, and you type 247. And that gives you 0.1594. 0.1594. Am I going to put a plus or minus? No. The reason I'm not is because I took an odd root, not an even root. All right. Example 4. First of all, the x cubed is not by itself. I need to get it by itself. To do that, I need to divide by 3. All right, now that the exponent, the variable and the exponent are by themselves, I need to undo a cube. To undo an exponent, you use a root. So I'm going to take the cubed root. And that gives you x equals the cubed root, option 4, 28 divided by 3. And that gives you 2.1055. And again, you do not need a plus or minus because that was an odd root. You only use plus or minuses when you use an even root. And my last example, my variable and exponent are all alone, so I'm ready to take the root. And I'm going to take the 7th root. And again, I do not need a plus or minus here because this is an odd root. And that gives me 3.2702. I forgot what I said. 3.2702. All right, so we will practice more of those in class. All right, so the parent functions of all power functions are symmetric. If the power is even, then the function is symmetric to the y-axis. If the power is odd, the function is symmetric to the origin. That's easy to remember. O for odd, O for origin. So here's an example. F of x equals x squared. I need to look at that on my calculator. So y equals x squared graph. And you look at it, and you should agree that if I were to draw a vertical line through the y-axis, you would agree that that's symmetrical along the y-axis. You can fold the graph in half and it would be symmetrical. Now I do x cubed, and this one's harder to see, but that one is symmetrical to the origin. So this one is symmetrical to the y-axis, and this one's symmetrical to the origin. The reason is because this is even and that's odd. So, describe the symmetry of the following functions. Is it even or odd? So f of x equals negative 3x to the 8th power. Well, considering 8 is even, this is even, and it's symmetrical to the y-axis because it's even. This one says y equals x. This has an understood exponent of 1. 1 is odd, so this one is odd, and it's symmetrical to the origin. Plus, if you looked at it, you could tell that this was not symmetrical to the y-axis. And don't forget, you have a quiz on February 3rd. Thank you.